Mapreduce is a programming model or programming paradigm where the data will be get processed in a parallel fashion on top of Hadoop, right? So to process a data parallelly, the data also should be there in a multiple machines in the distributed manner, correct? If I want to process the data into multiple machines at a time, the data should be available. The data should be available in all the machines, right? So how it is happening? It is happening through a blocks, correct? It is happening through a blocks. So we know that we have seen in a HDFS how the data will store into multiple machines, right? Once the data is stored into multiple machines, in those machines there will be some daemons will be running. Those daemons are, if it is a data node, if it is a data node, what daemon is running in the data nodes? Task tracker. What daemon? Task tracker. When it comes to Hadoop 2, when it's come to Hadoop 2, node manager. When it come to Hadoop 2 or yarn, it is called node manager. And there will be one master daemon. What is that? Job tracker or resource manager. In Hadoop 2 or yarn, we'll call it as a resource manager. In Hadoop 2, the task trackers will call either task tracker or node manager. Clear guys how the Mapreduce architecture works? Now
Yes.
let's look at a detail, a little bit detail. So let me draw a diagram here. So to process the data in a parallel fashion, the data also should be available in the multiple machines. That's what we have to understand, right? If the data is not there in multiple machines, sure we cannot understand it. Correct? We cannot do a parallel fashion. If the only one machine the data is there, at max what you can do, you can launch multiple threads and you can process it. Correct? Or you can process it to multiple threads. Correct? But if it has to go in a distributed manner, the data should be available in the distributed manner. Okay, how it is happening? So okay, my data is there in the distributed machines, my data is there in the multiple machines. So how that data will be processing? How the data will be processing? As we discussed yesterday, when you submit a job, MapReduce job, the request will go to whom? Job tracker. The request will go to whom? Job tracker. While submitting a job, guys, we need to understand one thing here. Look at here. I'll be showing the command how to execute a job, and based on that we will understand. While you submit a job, either through command line or either through any tools, okay, any tools like Ashkabana or like Uzi, like any tool, any job scheduler, or your own no cron jobs, or your own shell script, whatever you write, will write a command such a way that Hadoop jar, because we are going to give a jar file, jar, path of the jar, and your driver class name, fully qualified driver class name, fully qualified driver class name. I'll explain each and everything. Class name, fully qualified means including the your package name, okay, and your input path. Now input path, suppose if you're launching a job on Hadoop, I mean distributed manner, this should be HDFS path and output path. So once the results come somewhere, it has to store, no, output path. Okay, so along with that you can give any other parameters as well, and so on. These are the main important parameters. These are the minimum parameters you have to give, and so on. You can give anything else. Let's look at the same thing. So this is a syntax, right? Let's look at an example. Let's look at an example. An example is Hadoop jar. My jar path is, let's assume that it is there in user. It's a local path, guys. Okay, user mr1 dot jar, mr1 dot jar. Let's assume that my class is com dot mr dot job1, job job. My class it is. This is my driver class. Com dot mr dot job. My class name. And what I need to give? Input path. I need to give input path. So let's say it's a job class to make it very much clear. Job class. Then what I need to give my input path? Input path should be HDFS. Let's say slash input slash let's say mr input 1 dot txt or whatever it is. mr1 dot txt. mr1 dot txt. Now I need to give the output folder also, right? Slash output output slash mr1. So what does it mean? I am submitting Hadoop jar. I'm submitting Hadoop jar which contains all the driver class, my mapper class, all my Java code. Ideally all my Java code. So the jar path is there here. The jar is available here. My jar is available here. You take the jar from here. And in the jar file, there is something called driver class. Driver class is nothing but entry point to your application. Entry. Suppose how we have a main method, right? In the core Java, here also we'll be having a main method in one of the class. One of the class will be having a main method. That class we'll call as a driver class. Why we are calling it as a driver class? Because it is a starting point. It is the entry point out of that class. Okay. Next, it will start enter into this driver class, and I have to tell from where to I need to pick the input. From where I need to pick the input. From where I need to pick the input. So it should be HDFS path. So pick the input path which is there in HDFS, and this is my output. Whatever the results comes, right? You keep the results in this folder. You keep these results in a folder. That's also HDFS. Okay. Now this input will be there in HDFS. If an input is there in HDFS means the input will be distributed across the multiple machines. Correct or not? I'm taking data from input. I'm taking the input from the HDFS. So my input will be available or distributed across the multiple machines. Correct or not? Anila, Madhusudan, Raghu.
Yes.
Correct? So now
Yeah.
I need to process the data which is there in HDFS. Correct? So how will I process? How will I know that you have given path? I understand. Okay, you have given path. Very good. But how will I pick? How will I know where the blocks are available? How will I pick? So as we saw yesterday, what will happen? What will happen? Let's look at here. Let's look at here. As soon as you submit a job, it will go to a job tracker. It will go to a job tracker and it will create a job ID, and it will, after creating job ID, your job tracker will talk to name node. your job tracker will talk to name node. After talking to job tracker, what it will talk? It will go and talk to name node saying that, because ideally it will be in the same, okay, it will be in the, sometimes it will be in the same machines. Very rare scenario, suppose you want to service should be separate machine, we'll keep it in separate machine. Most of the cases it will be running on the same machine. Now the job tracker will talk to name node, and it will understand that where and all the blocks are available. How it will understand? Your job tracker will talk to a name node by telling that this is the input path I have received. Please tell me where and all the blocks are available for this input path. Please tell me where and all the blocks are available for this input file. Then your name node knows about it because he will only guy who maintains the metadata. So he will tell to the job tracker, yes, I know the paths. These are the path here and there. So one block is there mission one block is there here and all, here and all, here and all. So it will give the blocks information to job tracker, and the job will be scheduled, and it will tell to the job, it will tell to the slaves. Who is the slaves? Task trackers. Okay, in your mission you have a this one, you launch this job. In your mission it is there, you launch. So what they will do, they know where the paths, now they got a work to do, and the work is that they have to execute some logic, the Mapreduce logic. Okay, first they will execute map logic, then they will execute reduce logic. We'll talk about that in detail later, and they will start executing on the specific data. This part is everyone is clear about the parallelism, parallel passion, about till here everyone is clear?
Yes.
Yes, sir.
Vaishnavi, Sunil, Sulba, how the parallel fashion works, till here everyone is clear?
Yes, sir.
Yes, sir.
Yes, sir.
Raghu, Madhusudan, hey, I want everyone response because from here it will be a little tough, so please concentrate everyone.
Yes, sir.
Right, good. Now let's look at so let me clear the screen. Okay, Ravi, you have told me the data will be distributed across the different machines and it will be processed from there. We understood that. How it is happening? How? So for the map reduce, what we need to do? We need to write two type of logics, two phases. Actually, it's a multiple phases, but in a very high level, when we talk in the very high level, map phase and reduce phase. And in between there are multiple phases, guys. I will show you each and everything. So map phase, what has to be done? Reduce phase, what has to be done? We will specify in a Java code. Okay. So what is the map? Why they have named it as a mapper? Map or mapper. Why? Because the data has been distributed across the data nodes. Your logic, your map logic, or your logic will map with each and every block, mapping, connecting. Look at here. If anyone is not able to look at here. We'll talk about this mapping worker to process. So the input data on HDFS is stored on the local disks of the machines in the H cluster. Correct? The input data will be there where? In the data nodes. Data nodes are nothing but in the local disks, in the hard disks only, right? HDFS divides each file into 64 MB blocks and stores the several copies of each block, in typically 3 copies in different machines. MapReduce master takes. Who is a MapReduce master? Job tracker. Takes the location information from the input file into account and attempts to schedule a map task on machine that contains a replica of the corresponding input data. Failing that, it attempts to schedule a nearest map. We'll talk about that. So this is called speculative execution. We already talked about it. We'll talk about that later. Okay, we'll talk about that later. So when running a large map, when running a large map reduce operations on the significant fraction of the workers in the cluster. Most input data will be read locally and consumes no network bandwidth. That's what data locality. Here the data locality comes into picture. Till date we have discussed data locality, but we didn't see what is the data locality, how it is working, right? From here the data locality will come into picture. So wherever the blocks are available, there only, wherever the data is available, there only I'm getting processed. That's why the data locality comes into picture. Look at, guys, everyone, the map phase. What is a map phase? Your input has been broken into pieces and kept into multiple machines. Those has been, your map function has been mapped with each block or each chunk of data or each piece of the data. The first phase of the Mapreduce program is called mapping. A list of data elements are provided one at a time to function called mapper, which transforms each element individually to an output. What is happening here? We know that the data is there in multiple machines. Your map task is, your map logic is mapping with each and every data block, and it started processing it internally. And it is a Java program. It will execute on the JVM. So it will launch a JVM and it will start processing the data on each data node. Suppose if they are processing, they will also get some output. Every data node will give some output. It may give an output, it may not give an output, because based on the logic, suppose I have given some logic, whether if it is available, you do something. If it is available, do something. If it is not available, it will not give any output. Correct? So most of the cases, each and every input will give some output. So that output will be right into local disk again. It will not keep in the cache memory, or it will not keep in the RAM memory. The output of the mapper will go to data node's local disk. This is very much important, guys. Please try to understand. Whenever the map logic is completed on the specific data block, the output will go to data node's local disk, data node's local disk, data node's hard drive. It will not keep in the memory. That's where the Spark is come into picture. We'll talk Spark later. So here each data block has been mapped with your map logic and started emitting some output. Clear about what is mapping? Mapping is nothing but mapping your logic with each data block in the cluster. I hope everyone is clear. Let's look at. So mapper phase. Then internally these things, I don't want to make you confuse what will happen after map. So as of now, we just understand very high level. As of now, you just understand very high level. One is the map phase, and whatever the output is given by a mapper, that will be input to your reducer, because it's a different phase. So mapper has performed some operations. It is given me some output that has to go to a reducer. So reducer lets you aggregate a values together. A reducer function receives an iterator of input values from an input list. I mean, what is this input? Map input is nothing but, reducer input is nothing but your mapper output. Your reducer input is nothing but a mapper output. What it is doing, it is collecting the different outputs, because in so many machines, so suppose I have a 4 machines and 4 blocks, 4 maps has been launched. When 4 maps launched, what will happen? Each map will give some output. Now I need to collect all the small pieces. I need to make it a single function, right? Or I need to make it a single output, right? What it will do, it will collect all the outputs and will keep it in a single phase or single. It will do aggregation. How the aggregation will happen and what basis it will happen, we will see now. Okay, first you try to understand very high level, then we'll see deeper. So that's my intention to make you understand what Redis will do. Then how it will do, we'll see. It will collect the outputs of the mappers and it will apply some logic to keep in a single output. Okay, it will collect all the outputs of the mapper and it will apply some logic on those output of the mapper, and it will make it a single aggregate or reduces the multiple outputs, reduces to single output. Okay, that's the reduce function. That is the reduce function. Clear about the what is the reduce function? Akash?
So how many mappers are there? Is that equal to reduce those many reducers
No,
should be available?
no, that's wrong assumption. That's what I'm trying to say. That's the wrong. So how many mappers are there?
Maybe,
Those many outputs will come. Correct? It may
Yes.
be less or it may be less. It may not be more. It may be less because one data block may give some output or not based on the condition, based on the logic you written. Let's look at here. Very simple. Let me keep it very simple. I have one data here. Let's say, let's very simple to make you know guys understand. Let's say I have some data block here. Let's say in this I have a I equal to 10 value. Let's just for simple, okay? But my map logic, my map method says if I equal to 10, I equal to 10. 1 second, guys. Then only you do some operation. Then only you'll emit the output. Otherwise, don't emit. So will it give any output now? Sorry, greater than 10. Greater than 10. Let's assume that. If I is greater than 10, then only you do some operation. So will this data block will give me any output? It will not give any output because it's I equal to 10 here. So that's the same way, based on your map logic, your data blocks may give output or may not give an output. Correct? Let's assume not everyone is giving an output. So if I have a 4 data blocks, I will get the 4 outputs. Correct? I'll get the 4 outputs. Correct or not? Srikanth, Akash.
Yes, fine.
Yeah.
That's fine.
So I will get the 4 outputs. Now these 4 outputs I cannot give to my client. I cannot give to my client. Client cannot understand the 4 outputs because one output files show has some values, another output file has some values. There may be duplicate values in other files as well. So it has to aggregate in a single value. That aggregation go with to reducer. It means these 4 outputs will go to a single reducer. Reducer will be single. Minimum is 1 and maximum is 2. As per the configuration, by default it will launch only one reducer, but you can increase them. You can increase them, but by default it will launch only one. By default it will launch only one. Okay, so it reduces the outputs of all mappers into a single. Let me show you guys here a little bit. First, if you guys understand our high level, no, so it will be easy to make you convince or understand easily. So that's the reason. So let's say here I have a file which is there in HDFS. Let's take a use case. Same use case what we used to discuss before. The use case is I have some data. I have some data of Amazon data. This Amazon data is last 6 months. This Amazon data is last 6 months data. Now I need to understand. I'll just take only 3 categories, guys. How many new registrations? The first one I need to understand new registration. I need to understand how many mobiles has been sold or how many laptops. Mobile count. How many new mobiles has been sold out. The third one, how many books. This is what I need to count. Okay. Last 6 months, how many people has been registered, how many mobiles has been sold out, how many books has been sold out. Based on this report, I want to start promoting, or I want to start a new new campaign or new product, whatever they want to take a decision. That's like the secondary. Now this Amazon data should be available where? HDFS.
Yeah.
Let's assume that this is HDFS. This is Amazon data. So this is Amazon data. This Amazon data will be break into pieces. Let's assume that it is, I want only 4 blocks. 4 means 64, 64, 120, 256. The file size is 256. I'm just taking simple example to make you understand. 256 MB is the file name, file size. How many blocks will come? The block is 64 MB. 4 blocks will come, correct?
4 blocks. Yes.
Okay, 4 blocks came. So this file has been transformed, or this file has been broken into 4 blocks. 4 blocks. Alright. So now I will write my map logic. The data which is there in Amazon. Now the data is there in Amazon. Now I want to process the data of Amazon data. I want to find out how many new registrations are there, how many mobiles has been sold out, how many books has been sold out. This is what I need to do. So for that I will write my map logic. Let's look at here. For that, first I will write my map logic here. Some logic, what type of logic you will write we will see later. Okay, some logic we will write. Okay, this says that take, suppose in the log file if you find a mobile and emit that. Let's say if I find mobile here, comma 1, I mean emit mobile comma 1. So suppose if I found book, emit book comma 1. If you find registration, regist comma 1. So like that my output will come from the mapper. And reducer, what it will do, it will take all the mobiles, it will do the sum of the mobiles, sum of the mobile, not all the sum of the mobiles, it may do sum of the books also, and it will do the new sum of the new registration. That's why I will count the total registration. Okay, let's say that this is my logic of reducer, this is my logic of mapper. Now as we discussed, each block will be mapped with what? Mapped with what, guys? Each block will be mapped with what? Guys, could you please respond to me?
Respective mapper.
Respective mapper.
Respective mapper.
Very good. So each block will be mapped with my map function. In between there will be so many other processes, we'll talk about them, but I'm showing you, I'm trying to make you understand first a high level, so I don't want to make you confused. So the maps has been, each block will go to respective block, whether each block or 2 blocks 1 map, or 3 blocks 1 map, or 1 block 2 maps. So those all these things we'll see, okay, in the little down. So there is there is a long way to go. We will see each and everything. So I have launched 4 mappers. Time being, you just assume that 1 block 1 map, 1 block 1 map, but time being, but that is not the fact. That is not the fact. The fact is something different, but time being you just understand 1 block 1 map. 1 block 1 map. It will read the data from here. And one more thing, guys, I'm telling, 1 block 1 map is just assume for time being, but in the actual scenario is different. It is not one block one map. There is something called input split. Number of input splits equal to number of mapper. But the time being, you just understand one block equal to one mapper. Okay. So whoever seeing this video later, don't get confused. You might have read somewhere like number of input splits equal to number of mappers. But what Ravi is telling, number of blocks equal to number of mappers. For just for time being, to understand the Mapreduce framework, you understand one block equal to one mapper. Number of input splits equal to number of mappers. This is so in this case your input split is nothing but a block. Just assume. Okay. Now after mapping, this will give some output to me. This will give some output. That output may be registrations. It give me registration. Let's say 4. Okay. This gives me registration 4. Mobile 10 and books 100. This map also will give some output to me. Maybe in this chunk of the data I don't have registrations. I have only mobile, which is 5, books, which is 25. Books 25. I don't have registration list. In this piece I have a registrations, which is 50 registrations, and I have a books. I have books 200. So this also gives some output to me. In this all are there. Registrations are there, which is 100. Mobiles are there because some festival season. So mobiles are 500 and books 550. Okay. Now if I give these results to my client, will your client agree for that? I mean, will your client so what will client will say? Will it be happy? Will he happy by seeing these results like this? What Ravi, one place you have given 4, you want me to calculate myself? You will say the next immediate word, what Ravi, you want me to calculate myself? Then what is the purpose of we have set up the Hadoop and all those things if I calculate myself as manually? Correct. This is the output of mapper 1, this is output of mapper 2, this output of mapper 3, and this output of mapper 4. Now all this output has to go to single file. Actually the output should be single, right? I cannot have outputs like this. So when I have everything in a single place, it's easy to understand. If I have everything in mixed and multiple places, so again I need to pick from here, suppose if I want to calculate registration for, okay, 50, 54, okay, 100, 154. So client cannot do that one, no? Not only client, even if you're running some tool, visualization tool, the visualization tool should have a total aggregated value in one place, right? So now what will happen? This output, this output, this output, and this output also will go to some process called reduce process. Actually there in between there are other 2 more. Okay, the copy phase is there, short and shuffle phase is there. So we'll talk very detailedly. Let's just this is very high level. That's what I'm telling in the beginning. It's a very high level. It will go to something called reducer. Reducer method. What reducer? What it will do? Sum of all. Correct. Doing sum of registration, doing sum of mobiles, doing sum of books. Okay. So what is the sum of the registrations, guys? Regis 154.
Out.
Sum. Now I need to do a sum. In the register, in the reduce logic, in the reduce logic is aggregation. The main purpose of the reducer is aggregation. To do the aggregation only, we'll use the reducer. Otherwise, you will not use the reducer. If you have something to do aggregate, yes, you go with the reducer. Otherwise, don't go with the reducer. You don't need a reducer at all. Okay. How many registrations are there? 150. Mobiles? 10 here, 5 here, 15,
550.
15, 5, 15.
565.
Sorry?
560. 550.
5, 15. And books? How many? 100. And here 25, 125, 325, 875. So now if I give this result to my client, he'll be happy or not? As a single output, if you give as a single output to my client, he'll be happy. Okay, everything is in a single place. You have aggregated everything and have given me the accurate values. Yes. So based on this, okay, there are more books as getting sold out. The next highest is 500. So registrations are not happening. More registrations are not happening. So try to give advertisement or try to give. Suppose if anyone newly log in, first time if anyone logging, I'm giving 500 rupees free. If anyone is logging, fresh registrations, I'll give 500 rupees into your account. If anyone is registering freshly or first time, I'll give the 500 rupees as welcome gift. And if any friend referred, the friend will get another 500 rupees as a gift. So that is a business strategy. That's way they will start doing promotions themselves. That's way they will start campaign, or by seeing the results, that is the way they will improve their business. Is everyone understand how the Mapreduce work in high level? If you guys understand, then only I can take you to code. If you guys didn't understand, if I take you to code, it's totally confused or totally mess. You guys understand?
Yes, sir, we got it.
Akash?
Yes.
Okay. Anila? Devashish?
Yes, Veera.
Okay, good, nice to hear. Okay, this is how the very high level works. Okay, Ravi, understand. This is how it's working. What is the code you are writing into mapper? What is the code you are writing into reducer? So what's happening in the mapper side? What's happening in the reduce side? And is there anything between the mapper and reduce? Yes, there are something. Okay, is there before mapper? How the mapper, let's say the data is a piece of data, how mapper reading it? How mapper reading it? It's not a magic, right? It has to read somewhere. The data is in the flat file, or the data is there in the block, right? So block in the sense one piece. So we have seen already how the data looks in the our data nodes. How data looks in the data nodes? How data looks in the data nodes? Let me show you. Blocks, correct. So if you go and see the HDFS data node, current, block pool ID, again current, that finalized subdirectory. In that there are some other, all names will be subdirectory only, guys. Subdirectory 0, subdirectory 1, subdirectory 2. You will never understand what it is, what it is stored here. It's loading. Okay, now these are the blocks. These are something like some files, right? These are the blocks. You cannot realize which block is belong to what. You cannot understand at all. Okay, that is not at all possible. You cannot understand at all. These are the blocks. These are blocks means it's something like a small piece of small piece of file. How this piece will read by your Java code? Are you writing anything to read a file? Are you doing something internally, like are you using any APIs like to read this file, or how we are doing? So that code part, we will see now. Understand how the blocks will be. These are the blocks. This is a block metadata of the block. This is called CRC file, or this is metadata of this block. We'll talk about that later. what this metadata will contain and all. Okay, we'll see that later. Okay, now how the piece of the file or piece of block is getting read in your map method? Who is doing that? Okay, now here there is something called input split. Now we are introducing a new terminology called input split. Okay, there is a new terminology called input split. Guys, please concentrate. This is very much important. If you didn't understand this, how your Mapreduce framework is working, how your mapper is working, you will never understand. Okay, if you didn't understand that, there is no point to, you cannot explain. Okay, you cannot understand. If when a problem statement given to you, if you know how it is working internally, you can, based on that, you can write your code. But if you didn't understand how it is working, so you cannot design your code, or you cannot design your algorithm. Okay, now let's take same example again. This is again my data block. Okay, so again this is summation. Okay, now we know that the data has been broken into pieces. I'm just taking here very simple small less pieces so to make you very much. I'll just only 3 pieces. I'll just take 3 pieces. This is HDFS. This is also HDFS only. These are there in the data nodes local. These are all blocks are there in the data node local. Okay, these are all blocks. Okay, HDFS, and I mean these blocks will be there in HDFS only. I'm showing you a little. There's a file. Okay, this is a file. This file has been broken into these blocks. Now these blocks are nothing but, as I shown in the background, if you see here, these are like a block blk underscore some number, blk underscore some number. These are the blocks. How those blocks will be get read? Okay, to read that block, I have some API called input split. I have something called input split. What is input split? Now we need to understand what is input split. Input split is a logical representation of a block, logical representation of data of a block. What is the logical representation? Your blocks are physical, but your the physical data, I should know from where it is, from where to where it is occupied, or what, from where, suppose I want to process this block, from where to where I need to process, from where to where I need to process, from where to where I need to process. Suppose if I start from here to start reading the file, I need to complete it here. That's my one block. That comes into one block, correct? So what it is doing is it is understanding the logical representation of the block. The logical representation of the block. Try look at here. So what is the input split will do? The input split will do, first it will understand, okay, this is the block. Actually it has some algorithm, guys. It has some formula. We'll see the formula. So we don't have much time to see the formula. We'll see the formula next slide, next video, or next class. The formula is, it will try to calculate from where to where I need to read and how to read. Okay, your input split is a logical representation of a block or logical representation of the data. That's why it is a logical block. Your input split is a logical block. Okay, so your logical blocks knows. Go ahead, guys. Someone is asking me a question. Someone is asking me a question. Please go ahead. Okay. So the input split is a logical representation of the block which will process by single mapper. It means now I'll now what it will do, it will find the input split. How this input split will be how the input split will be calculated. This input splits will be calculated, or this input splits will be generated based on input file format. What is input file format? Yes, MapReduce work on, or MapReduce uses what type of data you are using. Are you using text data? I have something called text input file format. If you are using text data, I have something called text input file format. Are you using sequence file? Yes, I have something called sequence file input format. Are you using something else? Yes, I have something else for it. Okay, there are something called input file formats. Simple guys, to keep it as very simple, input file formats are nothing but what type of data you are giving to your map logic. To understand the data, you have some different class called input file format class. What is input file format class? The input file format tells to your MapReduce program or MapReduce framework, this program is going to design based on this type of data. The type of data is nothing but text data, or it is a sequence data, a sequence file data, or is a different kind of data. What type of data it is? Is the data is a text data? Okay, my whole MapReduce program will process text data. So the logic will be text, the logic for the text data. If I have something called tab separated data, columns, there are something column wise the data is there. Let's assume that. For that, I have some other logic with some other file format called key value file format, or I have something called sequence file. So my map logic has to be as per the sequence file. Suppose I'm getting data in the format of binary, I'm trying to read the data into text. No match, it cannot read the data. It says that I would go guy or go man, like you said it's a binary file and you said it's a text, your logic is text, but the file is binary. How can I read it? I cannot read it. So your MapReduce framework will understand first what type of data I'm going to process. So who will tell that? Your file input format will tell that. Who will tell that? The file input format will tell that, yes, I'm going to process this data in a way of text. So I have to use a text input file format. Okay, suppose I'm going to process a binary data. Yes, if it is a binary data, the data is coming in the binary format, which is not in human readable format. Let's assume that. So I have to tell to my MapReduce, hey, the data is coming in the form of binary. You read it in a binary only. You process it in a binary. So how will you tell? How will you convey that? You will set your file input format. You will set a file input format. The file input format is the most important thing. Your MapReduce works based on the file input format. You will write your logic based on a file input format. Your MapReduce framework work based on the file input format. We'll talk all these things. Now it is maybe a bits and pieces. So when you understand the very high level, I'll keep everything in a single slide and I'll make you understand. Okay, your input splits will be calculated based on the file input format. So I'm repeating one more time, guys. What is a file input format? File input format tells to the MapReduce framework what type of data I'm going to process. What type of data I'm going to process in the MapReduce. What type of data? Whether it's a text data, whether it's the data is coming from database, you have something called DB input file format. The data is coming in the binary format, I have something called sequence file format. The data is coming as a key value pair, I have something called key value file input format. Okay, so these things we'll see very detailedly tomorrow onwards. Okay, so that's it for today, guys. So if you guys have any doubts, Please stay back and ask me. Else, leave for the day. We will meet tomorrow.
Okay, Ravi, thank you.
Is there anything that we need to do? Is there any set something?
Could you please repeat? Oh yeah, yeah. We need to do one thing. I'll share one video to everyone. The video tells that how to set up a MapReduce in your Eclipse. Like some of the are you guys like to go with Maven, or are you guys go with a normal? Because most of them are not from the Java background, so they may get confused with the Maven. So we'll go with the normal way only. I'll share one video today. That video tells you that how to set up our Eclipse for the MapReduce. So I'll share that video. Please follow that video, and I'll also send you a document for that. Okay.
Thank you.
Anila, we are using for Java Luna or Kepler, right? So either Luna or Kepler is fine, but a older version of them, I mean, they may give some compatibility issues. So we can use Luna or Kepler. I feel Luna is good personally because I have used it in my production and my development environment. Okay. Thank you guys. Thanks for your time. Have a great day. And who are in US, have a great evening.